Okay, so here's the stuff you got to know for our graphing test number 2. Basically, we've got parent functions like y equals x squared, and the square root function, and the 1 over x function, and the x cubed function. These are all things that you should be able to fire off really quick. And, you know, if I say x cubed, you should be able to sketch that. Why don't you try that right now? Sketch x cubed. In case you've forgotten it, you're going to be hurting on this test then. There's actually a way to get around it. You won't be able to use your calculator, but there's another way, and I'll show you that backup method in case you blank on one of these. You got to know piecewise functions. I'll be showing you those, and sawtooth functions. That's like that worksheet we just created. Generally, those are pretty easy, I hope. And then other just little stuff that we got to make sure you're good at. All right, so let's start talking about parent functions. Did you, on your x cubed one, have it generally looking like that? Okay, good. What function is that one? Absolute value. What function is that one? X squared. One of the toughest ones. What's that one? 1 over x. Very good. Okay. So those are some parent functions. And then how about if we transform them? Well, that would mean, like, let's say we take this one. Let's say we do y equals 1/3 of x cubed minus 1. Actually, I should have the cube there. Sorry. And then plus 4. All right, that'd be as tough as they would possibly get. You got like 3 things happening there. It's not hard to say what happened. It moved, what's that? To the right one, and that's the first thing you should do. All right, so I take this whole thing and move it to the right one. Doink, done. Next, should I do the 1/3 or should I do the 4? 1/3. That means it's going to be 1/3 as tall. That means every point on this thing needs to move to 1/3 as tall as it used to be. So instead of 1, this one goes to 1/3. Instead of, it looks like this is at 3, 3, so it should go down to about there. See what I mean? So this spot there, move down to there. And then these that are higher, like really high, it gets hard to like move them down. But generally speaking, if I graph this thing, it's going to look like somebody took the ends of it and squished it down. Let's see here, it's 1/3. I'm trying to figure out what 1/3 of the distance from there to there is. That's about 8, so it should be 8's not a nice number. Let's say it's about 6. It'd be about 2, so it'd be like that. So, all right, see how that one's been kind of squished down? 1/3 as tall as it was. Then this plus 4 here means the whole thing needs to be moved up 4. Grab it, you move it up 4. 1, 2, 3, 4. All right, so that's generally what it should look like. If I get rid of this and all these points. Now, how can you be sure you're right? It's really important. How to be sure you're right? Okay, if I want to be sure I've done this right, there is a backup method. Okay, so there's I'm going to show you a video clip. I don't think I'm going to put it on the recording though, so I'm going to put now you can do it. Okay, yes, I was not recording for a second there. So I'm just trying to show kids how you can be sure you're right, giving them a safe way to check themselves. So I stuck in the number 2 into my function, and then I found out that 2 gave me 4 1/3 when I stuck it in here. And it hit my function perfectly, so I knew I did my function right. So do you care if you did it right? Well, you should, because you only get 8 questions, and if you get one wrong, let's say you had a 7 out of 8 going, you get one wrong, you get a 6 out of 8, all of a sudden you're at a B, if it was one of the hard questions. You know, so every question can knock you down a whole grade. So yes, it's worth checking. I want you all to put in your head the number 1. X is 1. See how easy that one is? What's the answer? 1 goes with 4. See, over 1 up 4. I nailed it again. But I bet you, because the ends are kind of where I'm a little rough, those aren't so great. I bet you if I put in 4 that I probably didn't nail it. So I'm putting a 4 here. Help me with this. What's 4 minus 1? 3 cubed is 27. 1/3 of 27 is 9 plus 4 is 13. So I should go to 413. I have 4 going with like 7.5. Way wrong. It should be like up there. You see what I'm saying? See where I can test myself and make sure that I'm not doing it wrong? All right, so that safety method will work for you. You can always make an XY chart and stick the numbers in. All right, let's do a couple that should be easy for you. Let's say, pull a graph in here, that I asked you to do absolute value of x plus 1, and then put a 2 out in front of that. So y equals 2 times the absolute value of x plus 1. If I ask you to graph that, give it your best shot on your paper. It can be a sketch, but I hope you know how to check yourself. For me, I'd always start, if I'm going to try to do it this way, I'd start by drawing the parent, and then I'd do it in order. I'm starting on the inside. Which way should I move now? Left one. That 1 in there means left 1. And then that 2 in the front means twice as tall. So all my points need to go up twice as tall. This point right here doesn't have a height, so it doesn't go anywhere. This goes to twice as tall as it was. This was at 2, it's going to go to 4. This was at 3, and it's going to go to 6. So there we go. And again, I'm going to double each of these things. There. There we go. My blue line is it. How could I test myself to be sure I was right? I could make a little XY chart. And I could ask myself, well, I think this point works. That's the point 0, 2, right? Test and see if 0, 2 is, in my little XY chart. See if 0, 2 is really in there. Stick in a 0. You see how I get 2? So it works. So you can double check yourself with this backup method. It's smart. I have a lot of kids that use that as a backup, especially on test. Okay, let's move on. Sawtooth functions. So there's one. Now, f of x is the original. That's what they give you. If they want you to do this, I'd like you to sketch what you think that would kind of look like if you do a negative like that. Yes, sir. The videos have not been working lately because YouTube, for some reason, is not accepting them. So I can't promise you videos for the next few days. I'm sorry. But starting about a week ago, they started to crash. I'd upload them, and then they would crash after I uploaded them. And it's happening to other teachers too, because other people have been emailing me and saying, what's with the videos? So I can't promise you a video. Just be happy you're here right now and you're learning them right now. I'm trying other ways. I'm going to be trying to post them through another site called Vimeo, which for you won't matter. You just click on a link either way, but that should, I hope, fix the problem. It is possible that our recording program has gotten corrupted. It says it's recording and it's got a file. It's all when it's all done, but there could be something weird with the files that are coming out of our recording device here. So it could be a problem on YouTube's end. It could be a problem on my end. Anyway, if I'm going to do this, it's a flip the left-right way, because anything on the inside is a left-right thing. So that's a left-right flip. So I'm going to take all my points. I'm going to think of this as a collection of these points. And I'm going to flip those points over. Some of you may be able to flip the whole thing in your head and just see, oh, I can see it's going to go like this. It's no big deal. Okay, and you would have gotten it wrong because it's not accurate enough. Okay, because these aren't supposed to be the same height, are they? And I made them the same height. So got to be careful. I'd like to think of each point flipping across there and say, all right, to get this point to go across, I'm going to go straight across here and drop it right there. And this point goes straight across over here, and I drop it right there. And I'll just keep going like that. This one goes over here. This one here at -5, 1 goes to +5, 1. And this one here at -6, 0 comes right there. And then I just connect my dots. That's probably confusing because I did it in the same color. I'm going to use red. There's my final answer in red. See how that was flip, left, right, flip? You going to be good at that on the test? Is that, hopefully that's pretty easy, isn't it? Okay. All right. How about this one? You'd take each point and make it 3 times taller, and then you'd move it where? Down 6. So watch me make each point 3 times taller. That point doesn't change. This point, that's right here. I'll make my originals in red. I'm going to make each point 3 times taller in blue. That doesn't change because its height was 0. 3 times 0 is still 0. Height was 1, now the height's 3. Height was 2, now the height's 6. Height was 0 is 0. Height was down 2, so I go down 4. Connect my dots. What did you... Where am I... Okay. I think I understand what you're saying. I haven't moved it down 6 yet. Do you get that it's 3 times farther down. Okay, I'm sorry. Okay, 2, 4. Okay, I get what you're saying now. You're right. That should be down there. And now I can take this whole thing and move it where? Down 6. So I'm going to take my green pen, and for each dot, I'm going to move it down 6. 1, 2, 3, 4, 5, 6. Put a dot there. And then this one's 1 above that. No, wait, it's not. Dang, gotta be careful with that. Down 6 from here. 1, 2, 3, 4, 5, 6 right there. Next one, move that one down 6 is going to be there. And then this one down 6 is going to be right there. And then this one doesn't move. Oh, wait, that doesn't make sense. Move it down 6. Duh. It's complicated. And then the last one, that one, down 6 is already down 6, so I got to go down to 12. It's like way the heck down here. Okay, and then I connect my dots. Doot, 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 doot. There we go. What if I needed to be sure I was right? You can't actually plug points in on this one. It's not gonna work as nice because you don't have a original function. I could take an original point that was in this and times it by 3 and then subtract 6 from it and see what the y would be. I could do that. All right, moving on. This is a sawtooth function. It doesn't happen to be sawtoothed, but it's kind of rounded, and it brings up 2 important points. What happens when you do the absolute value of them? You need to know this. The absolute value of the f of x means that they have absolute valued the y's, which means the y can't be negative anymore, which means anything down here, that's where y is negative. See, and then up here is where y is positive. The stuff where y is positive, I just leave that alone. The y's that are negative are the ones that are going to change. So the guys that are down there have to change. They have to move to, like, for instance, that little loop needs to go up here instead. So my final answer would be like that. Most of the graph is exactly the same as it was, and the part that was negative flips up. Do you get that? Raise your hand if you get that. Okay, good. Next part is f absolute value of x. Well, that's taking the x's and absolute valuing them. It's more complicated. All right, on that, what you have to ask yourself is, where are the x's negative? Because that's going to change. The x's are negative over here. So in that zone, the x's can't be the same as they were. So I get rid of them. So I erase everything that's over there. It's all gone. And now, anytime I put in like a -2, my function will think I put in a +2. So it's going to end up mimicking this graph right here, except wherever the negatives were. So bottom line is, it just reflects it over here. So the fact that it was like a little squiggly-do over here, it's gone now. That part just gets erased, and this part gets reflected across there. Final answer is both parts of the graph. I'd like you to try that one, except I'll make it a little different picture. Let's say it's I'd like you to give me 2 graphs. This is f of x. I want absolute value of f of x. And I'm going to do that in green. And then I want f of absolute value of x. That. Sketch what you think the two answers are. Okay, so the first one, all the y's, see f of x is y. And all the y's need to become positive. They can't be negatives. So this part that's looped down there has to bounce up, and my final answer looks like that. Raise your hand if you had that one right. Okay, good. And the next one I'll do in red, and that is absolute valuing the x's. That means everything over here on the left side needs to disappear, and then whatever was on the right side would get reflected over here. Final answer, again. This is the axis I'm drawing back in here. Any questions on those? All right. Sounded like a Minnesotan there for a second. On those, take a look at this piecewise function. I'd like you to sketch what you think it would be. It's got two parts to it. It could have 3 or 4 parts. It's got domains kind of built in. Numbers that where it's defined. So the function only works as x squared between 0 and infinity. Do you get how that's here? Between 0 to infinity, that starts at 0 and goes to infinity, it's the x squared thing. This other part is negative x minus 5. Well, basically, in this zone right here, that function is negative x minus 5. Well, what's that look like? It's a straight line because it doesn't have an x squared in it. It's not quadratic. It's not a parabola. It's just a straight line that has a y-intercept of negative 5 and a negative 1 in front of it, so its slope is negative 1. So it's just a line that would run like that. But what's wrong with what I just did? I went too far. I went too far to the right. See, it shouldn't be over here. Because see, right now, this thing wouldn't pass the what? Vertical line test. So it wouldn't really be a function. Because it'd have 2 outputs at that endpoint of like 1. You'd have 2 different outputs. Okay, so I have to get rid of this, right back up to the dot. And the thing I warned you about on these is the endpoints are going to be really important. So that green thing should have an open circle at the end, showing that it is not at 0. And it's darkened in circle here, showing it is evaluated at 0 there. And then the other endpoint that's missing is on this end. I need an arrow saying that's going up forever. Now I've got a perfect piecewise function. Any questions on that? All right. So that covers, for the beginning here, we talked about all the parent functions, not every single one. We talked about all parent function. We talked about piecewise. We talked about the sawtooth ones. And on those, we did the absolute values. Here, I have a few more little things. I already talked about the safety zone, a way to make sure you're right on your graphing. Now we should talk about vertex form and odd and even functions. So here's vertex form. Remember how if I have a parabola, you've done this back in higher algebra, that spot right there is called the vertex, right? And if it's over 2 and up 1, 2 comma 1 right there, then what's its equation? You should be able to just write the equation. It starts with y equals x minus 2. And you're really close. I'll just finish it. Squared. Because it's a quadratic. You get what I'm saying? All right, I want you to tell me if I had a parabola that was like over here at negative 5 comma 1, what would its equation be? Don't say it, write it. Keep engaged with that writing hand. Okay, BD, what'd you get? Yes. Don't have it yet? All right. It looks like this, except that it has different numbers in it. So, come on, you can do this. Yep. It's not right 2 and up 1. It's this. What's that one? Left? How far? Okay, here's the original one. It looked like this, and it moved to the left a bunch, and then it moved up. Come on, you can see the numbers right in there. All right, I'm going to call on somebody else because you're obviously having a brain block. So let's go up in the front row here. You say +5. What does that +5 mean? Left 5, and then +1. So final answer, x plus 5 squared plus 1. Raise your hand if you had that one right. Okay, good. On to one more, just to make sure everybody gets this. Let's put one here. And let's say that's at the spot -4, 3. No, -4, -3. Okay, what's the equation for that parabola? Mr. W? Dang it, I thought you'd screw that part up. But he didn't. You remember there's a negative up front. Why is there a negative up front? Because the thing's upside down. All right. If the parabola's upside down, you need a negative out in front. It's very easy to forget. All right. So that's vertex form. Last thought? Yes? Question? Nope. You can be asked to do the same exact thing if it's an absolute value. And the only thing that would happen, for instance, on an absolute value is you'd be straight lines instead of curves. You know what I mean? It's exactly the same. And if it was a square root, this would all be under a square root. Okay. All right. Next, let's talk about those. What is it again? Odd and even. Okay. So here's odd and even. This is an even function. Do you remember that? Is that an even function? Yes, because it has a line of symmetry right down the middle of it. Is that an even function? Yep. Is that an even function? No, that's an odd function. Remember the odd functions? They're graphs. Notice I said the word graphs. See, this is all about graphing, right? First it's a reflection this way, and then it's a reflection down. So it's a double reflect. It's like a reflect this way and a reflect that way. All right, so that's one way to think of the odd functions. So if you see a picture, and I say, make that an odd function by filling in the rest of the graph. Well, if you did this, you'd make probably the only other logical mistake, and that would be to say that you just made an even function, right? And then if instead you do a flip that way, and then you do a flip this way, flip, where's a flip? Flip, up, down. Then I have to slide it down. There, I did a double flip. Did a left-right flip, and then an up-down flip. In fact, I bet I could do it with this. I could say flip, left, right. Then I got to slide it over. I really wish you didn't have to do that, but and then flip, up, down. There we go. Okay, so there's a bunch of things about graphing that you've learned before. Now, what do we do with our last 15 minutes or so? I have a review worksheet for you. The answers will all be posted tonight. You can work on those. We also graded a homework assignment in class today. It was out of 8, so you're going to give me that score. I think we have another one in the grade book that's missing. It's a book assignment, page 147. Find it. It's already been graded in class. Some of you might have not had yours graded yet. Then you need to say, mine hasn't been graded, but it's page 147, and it was out of 7. Did we already put it in on Friday? Oh, cool. Awesome. Actually, I don't need to be recording anymore, though.